Cheers, thank you. So I'm Matthew Larbey. I'm the Managing Director for EMEA for EDGECONNEX. EDGECONNEX is a builder and operator of edge data centers. And I'm going to go through just a couple of the challenges that we see in the market today, what we've seen historically, and where we also see some of the challenges that we've seen in the past and how they're going to impact in the future going forward. From the experience that we've had in the content space and the cloud space and increasingly into IoT and a few other future services, we believe that this Internet of Everything requires an Internet of Everywhere. And what that's actually doing is driving a need to re-architect the Internet for today's traffic flows. The Internet was never really designed for the traffic flows that are flowing on it today, and they certainly weren't designed for what's coming into the future. So we're seeing a massive transformation of infrastructure, both at the data center level, the network level, to manage these types of services. I'm sure you've seen plenty of these types of slides today, but there's a few that we'll call out. Just the volume of data is obviously increasingly massively. We're also seeing a shift in services. So today, if you take something like gaming, there are today gaming tasks that exist in the cloud. So if you're on the PlayStation Network or Xbox, certain tasks, certain functions are provisioned within the cloud, and there's a sharing between that and the localized device in the consumer's home. But increasingly, we're seeing that being offloaded, and you've seen announcements from, obviously, Google with Stadia. You've also seen announcements from Microsoft with xCloud, where all of that provisioning is going to be done in the cloud. And that has a real impact in the way that these traffic flows are used for response with latency. We're also seeing it with the coming of 5G. We're also seeing it with machine learning and AI, so packaging up analytics to apply in certain industries like pharmaceuticals, oil and gas, heavy research, where traditionally that would have been done as an on-premise solution, but increasingly now companies are wanting to buy that capability off the shelf. There's been a lot of talk about smart homes, cities, and industries. We're certainly seeing that in the IoT space. Autonomous vehicles, everybody puts up. I'll share some of the use cases that we've been involved in. It's still in very early stages of edge processing for autonomous vehicles, and we'll talk about a few of the challenges around there. I thought I'd put this slide up just to really show the kind of difference. One of the key ones to call out, you probably can't see the numbers, but in 2017, total hours consumed on Netflix was, in a minute, was 70,000 hours. Sounds a lot. In that same minute, in 2019, Netflix is 700,000 hours. So it's an exponential growth that we're seeing. There's a stat down here that Netflix is taking up about 15% of traffic. Actually, the new statistics that came out a couple of weeks ago, they've actually dropped a little bit. So they're about 12% now of all the internet download traffic globally. Some markets are higher than others. But they've actually been overtaken now by the aggregated HTTP streaming services, HBO Go, ESPN, Hulu. They now account for a much larger share of the internet traffic. So we think that the edge is actually not defined by us. It's not defined by forums. It's actually defined by the customer. And we believe it's that lowest demarcation point between the service and the consumer. And that can be two ways. That can be a service like video streaming and a consumer like you or I watching that, or it can be a service for uploading analytics into IoT, machine learning, where the source is actually a factory floor or a test bed or an autonomous vehicle. So we've really had to think about how we architect our data centers, both at what we term the hyper-local, the really, really, really small, sitting in a base station, in a cell tower, on a factory floor, multiples into smart cities, but also how that scales up to effectively hyperscale, the hyperscale core. So we deal with everything from effectively what we term hyper-local to hyperscale. It's really important for us that we see, particularly with cloud on-ramps, that there's this merging of, everybody talks about hybrid cloud as a path to public cloud. I don't think that's the case anymore. I think that the hybrid is the way that it will always be. Even Microsoft themselves are saying that they don't expect everything to be downloaded or uploaded into the cloud alone. There is going to be this hybrid model. So most of our reference architectures work with the local MSOs, the eyeballs, the networks. We work with the cloud on-ramp partners. We don't run our own SDN. We believe that there are very good third-party independent players in the market that can do that much better than we can, so we partner with them in that market. And it builds this overall ecosystem to enable these types of new services. So we talked about kind of cloud gaming as a use case, and again, our reference architecture is primed for this. If you think about the challenges of latency when you're running gaming services within the cloud, but you need to be under 10, 8, 7, 6 millisecond response times, you have to architect the network, the processing, and the storage in a way that effectively you are giving the consumer a choice between a service that runs directly in their home or one into the cloud as a pay-per-use model. But it needs to be the same experience. It also actually brings in a lot of features that you wouldn't necessarily have. You know, they themselves have said their secret sauce for doing this is the technology that they have in their data centers. This cannot be done in 4 or 5 very large data centers around the world. This effectively gets architected over 60, 70, 80 data centers of varying sizes to be able to get the processing and the experience as close to the consumers as possible. We also see this falls nicely into IoT. If you look at what Werner has said, really, the IoT really falls into 3 things. Law of physics, which is the speed that you can transmit something. The second is economics, how much it actually costs you to do that. And the third is law of the land. Well, law of the land is there a data sovereignty issue where you can only keep that data into certain locations? Again, it's pushing that processing much closer to where it's being generated. I think everybody's probably seen a slide like this that talks about autonomous vehicles. We're actually doing some proof of concepts at the moment with self-driving autonomous vehicles. And while these types of slides talk about the data generated by the cars on an ongoing basis, actually at the moment, a lot of the proof of concepts are in the learning phase. So these vehicles are out, they're driving, but they're bringing in massive amounts of data that need to be ingested by the servicing to do the analytics, do fault finding, better planning, to upgrade the software. And the only way that they're able to do this at the moment is they drive the vehicles into a dock, they remove the hard drive, they plug the hard drive directly into the data center locally because they haven't solved the local bandwidth challenge. There is just still, in the learning phase, too much data that to be transmitted across a Wi-Fi or a 3 or a 5G connection. The bandwidth just isn't there. So although they've solved one part of the problem, which is get that data into the cloud as quickly as possible from an edge-enabled on-ramp data center, actually they still are struggling with the initial phase, which is how do I get that sheer amount of data off a vehicle? So they go old school. This will get solved over time. Once they get to a certain point that they can release these onto, then the level of traffic comes down. But certainly this is a massive challenge today, and we're seeing this across a number of different industries. So as I said before, really this is just the summary of what we do. We build, as I said, from this kind of hyper-local with micro-edge, very small data centers that go onto the factory floor, they go into the cities. We do deal with the edge for content, medium size data centers, but we also do the core. You know, these are massive 40, 50 megawatt core facilities, mainly for the large cloud providers. So we believe we have a growing platform for this digital economy from an edge perspective. We're currently over 40 data centers, 31 markets. Interestingly, we do have over 200 hyperlocal edge installations. So these are the very, very small ones which are now growing at the same pace as the larger facilities. Thank you.